Okay. L- I don't like this noisy music. Testing, testing, testing. First, we gotta see where's this. This is Kate Coffell. What is this noisy stuff here, bro? Wow. The Dolomite. Hmm. Okay. Given a string containing our order English. Hmm. We send the digits in descending order. So like, didn't you just map from string to integer like this? And in ascending order. Is Python 3. Yep. Okay, so probably can use two dictionary. One to find these numbers. Because we have to map these back to this, right? Okay, so word digits word string. Let's do digit word to string digit. Okay. Mhm. So first we gotta somehow figure out how many example one here. Let's figure out the example first before we jump into this. So this give 1 0 1 2, right? So as we look through this, we would construct. What can we do? Okay. So let's say we have A B C D. We would ask like, okay, we look through 1 2 3 4 5 6 7 8 9 10, right? Oh, okay, so we would ask like how many 0 1 2 3 4 and so on, right? And we look through again and just spit out, right? So digit, let's call this digit word frequency. We want oh for digit word in, right? 1 0, right? 1 2 3, I guess. 5 6 7 8 9, right? And we would ask, is the can we find that in there in this word, right? So we would go yes. Oh, we can just convert this to a set, right? Right. So basically, if in SS, right, we DWF with this, and we do DWF, if not in DWF, DW 0, then DW F DW plus equal to 1, right? Okay, can we turn this into a dictionary? Expression, right? Dictionary comprehension. Whatever, if we do that later, let's figure out. Okay. And then we need a mapping, right? From digit string, right? DS 0 0 1 is 1. We can actually string of I for I in range 10, right? So we basically now have to result equal, right? Oh, we can just return right. This join, right? We say that for digit word in if digit word in DWF, then DWF of the word, and we need to do it, put it to the mapping, right? Oh, this is probably the dictionary as well. What was that? What was that sound though? I don't know what that sound is, but because this give us like how many, right? And do this. Okay. 0 0. Okay, so this gives us like a digit word map to number of time appearance, right? And then we still need to say that, okay, if the key, we need to map the key 0 here to the string 0, right? Oh, okay, let me just type them. Right, so this is actually going to be in ds.key, right? Right, so ds.key, right? So now we're gonna do is ds with dw multiplied by dw this, right? Wrong here, and 0 here first, and can we not do this? dw, right? Unexpected. Oh, yeah, I see. Forgot the in here. Okay, this will be, let's do the oh, we shouldn't convert it to the setup. First let's do a loop to here. C in so we have a word like, for example, 1, right? we need to check if one is in. Okay, so let's do a frequency of SF for in a SA. If C not in SF, SFC for 0, SFC plus equal 1, right? Okay, so we gotta do for C in DW, we have to basically search if all the C in W here is in this SF, right? Which is for C in DW, right? If C in SF, right? So if the length of this, right, go to the length of DW, that means we guarantee that it is in the thing. So if DW not in DWF, DWF, DW equals 0, DWF plus equal to 1. Okay, so 0, 1, 2, good. Does it make any difference if we put this out into the variable, right? We'll try that. Submit. 0, 0. What? Use a test case. What we have here? We have 0, 1. What? Let's print the SF here. San Francisco. Let's go. Two. See? Hold on. Oh, this is actually SF of C for C in DW, C in SF. We do SFC, right? Let's save this. SFC equal this is actually SFC, whatever the first character is. Wait a minute. Fixes this case, but it doesn't fix the other case. So let's look at our first stuff here. This is for mapping, good. And then we will ask, okay, how many ones is there, right? So you found that, hold on, let's do this. So this one, if we, so this one we want to find, okay, how many time does one appear, right? So if we one, okay, so basically one here's the minimum, right? So 0 here's the minimum. Okay, I see. So basically when we have the SFC here, in this case, we gotta take the minimum, because that's where, see, even though this is 1 0 here, but if we find 1, it's actually the minimum of these, right? So we want to look at minimum of SFC, right? So we print this. Okay. Try that one more time. Oh. What's wrong here? Let's print out stuff here. Let's look at how does it do each, right? So print, be asking for DW. Why does it duplicate here? 1 4 times. Right, we will print SFC as well as, no, I'm not asking you, Google. also print SF. Then okay. Okay, when we ask for 0, 0, check the 1. Okay, good. Oh wait, hold on. So for example, like 0 here is 1, right? 3 here is 2, 3. So we gotta get the minimum of, for 3 is minimum of 2e, right? Or whatever, but this one also 2e, 18, 19. Right, but let's go over example. 0 is good. 1 has 4, right? The 1 here has 4, but is also matched with, why is 1 4? 0 1. Oh, okay, so 1 here is, the minimum here is 4. Why? Oh, because it has, I see. So 0 here is 4 4, but E here also match all these. Right. So how do we fix in this case? Hello, what's up? Beethoven. It's doing some problem. So doing a mapping actually bad. We just need to find like how many 0 is in there, right? That's it. Right, so in this case, the 1, let me write in the node this particular case, see if we can figure out. Page here, node. Note. Oh, this one also out. Okay, so you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So right now our implementation found 4 1, which is bad because O appeared twice, 4 times. O, 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 O. Right. So the minimum that we did here is actually not representation of everything, right? So you gotta somehow find how many 1 is in there. But if we found 1, right, it's also, if we're doing a dictionary, we also need to be careful because also match this. So 1 is basically has to have 1 0, 1 10, and 1 e, right? And in this case we found 4, so 0 is 9 even, right? So the first optimization is we can take the minimum, which is 4, which is also wrong. So one thing we can do is in this case there's 1s appear 4 times, or does 1 appear 1 time, because 4 just happen to N and E just happen to share with anybody, right? So this is right. So if we have like 1 1 1 1, so if we add a test case, right, so like 1 1 1 1, and then another one sharing with it is 3, right? So 4 1 1 3, and then we have 0 0, right? We have 0 0, so that number of 0 is equal, right? So run this, right? So this is actually correct. How do we fix this in this case? Tricky. So right now situation 0 is 1 2 3 4 0 is what? 4. N is 1, 2, 3, 4, and also 4. E is 1, 2, 3, 4, 5, 6, 7, 8, 9. So now we have 9. So what was that sound? Sometimes Windows just send you weird sound. Let me get some water. Okay. So in this case is wolf. Is 0, 1 appearing 4 times? Or 1 appearing 1 time? I don't think we can infer that, do we? So we might have to find a different approach. So if S is guaranteed to be valid, that means when we search 0, what happened with 0 is so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0 appear in 4, 0 appear in 2, 0 appear in 1. Right? So if we want to find how many zeros there first, so ZERO has to share some number, right? Otherwise, this is pretty tough. what we can do though is, as soon as we find 0, we cut it off, right? We remove on the string, right? Okay, so what we can do is, as soon we just go through, if we found a 0, a string matching this, then we remove that, and that's a good idea to explore, because counting the frequency lose us information on stuff. So let's just move this to solution 1. That doesn't work, right? So remove this here. Okay, so what we do is I equals 0, y I is less than this. We want to loop for I. We want to find 0, right? So we want to loop through. So actually what we want to do is ys. Yeah, right? So we want a DWF as well. Okay. So we want to find all the position matching the word, right? So we first do for want to copy. So what is it for DW in yes keys, right? Okay, we need to make a copy of ds dws equal to ds dot keys, right? Does it make or does dictionary key make a copy? Okay, let me do a list then. It doesn't, because I need to manipulate this, right? So basically, while this list has some stuff, I will keep searching using the for we need to, for if we found the position 0, right, we need to pop them up the thing here, right? So first we gotta say for I in range of S, length S, right? And then we need to say that we need to search for, so we need to build a search dictionary, right? So basically we need to look to this. What I'm thinking of doing is I found all these. I keep finding 0 until there's none, and then I keep finding 1 until there's none, keep finding 2 until there's none. And then I append to this list right here, right? So that I don't have the problem of, okay, 0 sharing with whatever, right? That's what I'm thinking, which is what I'm doing right now. Okay. Okay, where am I? Okay. Uh, let me think for a bit. Does having a frequency here it's less confusing for me to do the find the character, keep finding a word and pop them up the string here. It'd be like less confusing because they guarantee to be valid. That means if we found 0, that means that's the first character, right? So we will keep finding them until this list is empty here. Okay, so what I'm doing now is, it doesn't seem efficient, but that will do for now. So if si not in SF, for example, W is only used for 2. Well, that's actually a good idea. After finding all the 0, I think you can't immediately find 1 because oh yeah, that is true. Let me see. After finding all 0, I think you can't immediately find 1 because all the letters are shared with at least one more digit. I think you have to find other more unique one first. Yeah. So uh 2 is only used for 2. Oh. So I mean, you could find all 0 because Z is only used for 0. That is, yeah, I could do that. So if I see Z, right, that means it's definitely number of z is a number of 0 for sure, right? Could find or 0 because z is only used, but there's no such letter for 1. Right. Hold on. Let me think for a moment. He's saying that, yeah, I could do z first for sure. And then yeah, so I guess for finding 0, I can just find the z, right? So there's 0, the number of z is the number of 0. And to find 1 is shared with 2. And okay, w, yeah, so 0 and 2 makes sense. Z and 2 can be found first. uh 0 and 2, and does 3 share with anybody? It says E, right? But I guess I can find using H. No, H is matched with H, right? So F4 and 5. Okay, you can find 4 with R, right? 0, 2, and 4. Right. 3 and 8 is the same. Oh, 3 is, you can use it using R, right? I think so. So 0, 2, 3, 4 can be found. 0 is Z. 2 is W. 3 is what? 3 we can do R. 4. Oh wait, 3 cannot do for R, right? So 3 is not good. 4 can do U. And 5 have I, and 6. 5 can do V, right? 5 can do V. Makes sense. Right. 6 can do X. Wait. Hold on. 5 and 7 is the same. Okay, so 5 is no good yet. So 0, 2, 4, and 6 is good so far. 8. 8 is G, no? Yeah, 8 is G for sure. 9. So 9 share with 1. So the only thing left is 1, 3, and 9. Right? So 1, 3, 9. So 1 has what? 1 require you to have 1 0, 1 N, and 1 E. So 3 has 2 E. 9 has 2 N. Wait, hold on. Yeah. 6 can do X. Right. So the only thing we need to figure out how to search for without, because it's not unique, is 1, 9, and 3. Okay. Five. Say 5, 1 3 5 7 9. Oh yeah, 5. Yeah, I forgot. 1 3 5 7 9. Yep. Thank you. So how do we go about doing that? Do we look at what's the common between 1 3 5 7 9? Okay. So 1, the common is E. 9. And this is possible. To figure that out using the common from these. Right, okay. So maybe the first thing we do is for all the unique one, like 0, 2, 4, 6, 8. We found all of their numbers, and then we decrease the number of, so we get all the frequency, like number of letters. Then we delete the unique one off of it, right? And then what is left, we use, like, okay, if it has a combination of 0 and E, right, then we can try that. This is what I'm thinking, right? So we find all the unique one, we the unique one is 0, right? So we found, like, if you have 0 0, we found them with 2Z. That mean anything with 0 in the frequency will have to decrease by the number of Z, right? And if 2, then yeah, and hopefully what we have left is with 1 3 5 7 9. And we look at 1 has 1 0, a multiple of let me try that. I don't know. Let's see how it is. One sec, let me check my phone. One thing. But thank you for the suggestion. I'll keep trying. What is this? Someone got laid off? No, it's cool. You can try rebuild a frequency table only for the remaining, but I think there's an easier way. For example, H is U for 3. H is U for H is U for 3 and 8, since you already know how many are there. Oh yeah, that's a good idea. That's a smart idea actually. Right, so this is finding common um okay, so then one sec, I'll be back. Let me look at my who got laid off here. Mm. Who's all these people? And how do they send me messages? Hi. Oh, I had to reply to this person. Okay, me reply to them after this. Okay. So in order for us to find one, right? Let's go back and try to find one here. Right? So one is shared with who? So one has the, we don't want the n because the n share with unknown. The e also share with the unknown. So 0 here. 1, the o share with 0, 2, 4. Okay. So we need to find one, right? We need to know we know that the total for 0, so 1 share with 0, we write that down, 0, 2 and 4, right? So we know the total of these z, we know the, so 0, 2 and 4 give us we have this frequency of 0, 2 and 4, and since one share with them. Oh, no worry. Thank you for the suggestion, and have a good day, Weed Hoven. Thank you. I think I already follow you. Let me check. I did. You have a good day. Thank you for the suggestion. That is very smart. I'm just gonna figure this out, and then I go eat. Okay. So 1 is actually a total of 0 minus the number of 0, a sum of 0, 2, and 4. Yep. Here we go. So now, how do we get 3? Right. So 3 is where? 3 we can use H. So we want to know the total. It will be total of 3 share with what? 3 is share with 8. Right? 3 is share with 8. 8. I mean, it will be total of 8. Minus, total of H, the letter, minus the 8. Okay, so we got 3. Now 5. 5 is shared with what? So the thing we know is 0, 2, 4, 6, 8. Good. So now 5. 5. Can we use V or F? So let's figure out 5 share with what? 5 is sharing with 4. 5 is sharing with what? I is 6. Right. X is what? X is V. V is sharing with where? 7. Okay. E share with a lot of people. E is sharing with a lot. So we don't wanna use VE. So maybe so let me look at 7 first. 7 is sharing with And how many do we find? So 7 is sharing with 6. E sharing with a lot of people. 0, 1, 2, 3, right, 5. And itself 8. And then 9. Sharing with a lot of people. So V sharing with who? V sharing with 5. Hmm. Okay. So to find 7, you actually had to find 5. No. Okay. 3 or 8. So to find the, let me look at that logic. So if we want to find 3, 3 share with 8. So we need to put this to something that we know, right? So we know 3, right? So 5 share with, you can try 4. But so for example, to find 3, right? We can use T, H, R, or E, right? So H is shared with H, right? So then the number of 3 will be, so H is only in, H is only in 8, right? Oh, we find 8 with using G, right? So to find 3, it's gonna be the total of H, right? Minus the 8, right? Because 3 and 8 share the H. In other words, 3 plus 8 equal to the total of H, right? Okay. So to find 5, right, we can do F, I, V, and E. So we have to find a letter that share between the thing that the two that we want to know. In this case, for 3 we pick each. So which letter do we pick for 5? Okay. Is it F? We can try F. So 5 will be total of F minus a total of 4, right? Yeah. No, yeah. So that will be total of F. So 7. 7 we have S. E V N. Right. So which letter do we pick? We can do S, B, S. So share 6, right? So total of S minus 6. Yep. Okay. And then 9. 9 we have N, I, and then E. Right. So who's sharing with E? Do we do N or do we do I? If we do I, it's gonna be sharing with 6. So it's gonna be total of I minus the frequency of what? That will be, we know it I is what? I is matching 5 to 6. So 5 minus 6. Yep. That's what we're gonna do. So first we do is we have a frequency for character in S. If C is not in F, then FC equals 0. So Y C plus equal 1. Okay, that's the frequency. So first we want to pick 0, right? So F of, so basically now we have digit word frequency. Gonna be thing. So 0 we use C to find because it is unique. You can find the following today using the unique character to search. Right, so 0 we do Z, 2 we do W, 4 we do U, 6 we do X, no, 8 we do G. So first we gotta do is basically 0 gonna be F of Z in F and DWF Z. Oh, DWF of 0 F of Z, right? So if let's put this here. U in F and then DWF of 2 F of U. Oh, W, sorry. If U in F, UF of U. Oh, this is 4. Sorry. Six. If X in ah 6. What? Okay. 8 is G. If G in F, UF okay. Okay. So find one to find one because so one share one we can do 0, right? One has 0 share with 0, right? 0 2 and then 4, right? Right, so one has 0 share with these. Okay, so do we pick O? One share with 0 here. So so one will be that mean sum up the O minus sum up 0, 2 and 4, right? Okay. Okay, if we ask if O in F, that means we want be equal to DWF. Oh, and DWF 0, 0, DWF and 2 in DWF and 4 in DWF, right? Then it's gonna be DW up O minus DWF up 2 minus DWF up 4. Oh, missed 0. Like that. And we do the same thing here. So now we got 3. We got H share with 8. So then basically 3 gonna be the sum of the H minus the sum of 8. Okay. So basically if H in F and H in DHF, basically be consistent here. One character we do single quote. Okay. Will be, what is it? 3 H minus 8. Okay. So now we do 5. 5, we pick letter F because it's shared with 4 and 5, right? F share with 4 and 5. So F share with 5, 4. So that means 5 gonna be equal to sum of F minus the sum of 4. So we save F is in F and 4 is in this, then 5 will be F minus 4. Okay. Then we do 7. 7 we pick S. S share with 6. So with 6. Right. So then 7 gonna be sum of S minus sum of 6. S 6. Seven. finally we got 9. 9 we pick I share with 5 and 6, right? Hold on, I share with what? 5, 6 and 8. Okay, 5, 6 and 8. Okay. So 9. Basically we pick I share with 5, 6 and 8. Right? So 9 will be sum of I minus sum of 5, 6, 8. Okay. So basically we have to ask I in this and 5 in this and 6 in GWF. GWF, then 9 I minus GWF 5. Something like that. Okay, so what have we left is basically 4. We already have them here. For the word in 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right. So if DW in DWF, we have a result here. Result plus equal to DWF. Oh, DW multiplied by this. What happened? What? The error? Oh, sorry. So if it's in F, then this is F. Hold on. O in F. Okay, this is FO. This is FH. Ah, what's wrong? 0, 2. What? So we have we missed a 1 somehow. Okay, hold on. Oh, oh, we need the mapping. I think. So yes. Okay. So we output 02 instead of 012. Okay, so hold on. So let's print the F. Bigas ng buwara. Yeah, 0 have this. And 2 is correct. Alright, so we found the 2. Okay, hold on. Zero share with 0, 1. 1 is at 0 and then 8. Okay. So we pick 0 and 0 gonna share with either 0 or 1 or 2. Oh, so this is actually no. Right, so this is, we have 2 here, so or, right? So that this is just doesn't mean it is. And come up. If they are available, right? So we just need this. So basically all of these has to be if and 0 in DWS, and this is actually or, right? Maybe. satisfy a function. We call it in GWF, right? So given a list, the word, right? So we would return some. So we want to know for total equals 0 if total equal -1. Right? Basically, we want to say that and sum in GWF let's just do this, or let's just do or, and then basically we do this, right? So for EW in GWF, then return total, return total. So basically this is minus in GWF, pass 0 0 2 4. Okay, all of this is fine. This one also have to change in this to be or. Oh, sorry. Okay, so now we do in GWF 5 6 8. Okay. And this. It's a list. Okay, so what's wrong here? I'm correct now. Oh, we missed a 3 somehow. So in this case, it only have so 3 and 8 share a lot. Three are okay. Hold on. We need to find all the possible cases, right? So T H or E E, right? T share with what? We have to go to all those cases, right? Okay, so let's go back to this and look at one here. We have 0, 0 share with either, okay, one share with 0, 0, O share with 0, 2, 4, right? We do n share with 7, 9. We do e, we share with 0, 3, 5, 7, 8, and 9. Wow, that's a lot. But let's just submit this and see what we do. Okay, so we messed up the 3 case. Okay. THREE. So something messed up with 3. So we do T share with 8. Okay. So and then H also share with 8. T share with 8. H also share with 8. R share with 4. So okay, so this is the case. We need to do okay, so there's a 2 case if 3, right? If H is indeed a chef, elif T also works. T R. Okay, so if H, then okay, run. Okay. So here we do elif H in F and that T also works. But T share with wolf. T share with T share with 8 also. So in this case they have T here, right? Okay, so the case then will be T. Right. So we use test case, we run. expect 3, right? So to find 3e, we can either found to t, right? So if h, oh, t, my guy, my guy. Right? Oh wait, hold on. T and also 8, right? What's wrong? Oh, this is the case where 3 isn't alone, right? So eventually we want to find that LF. Right. Okay, so we want to find the function EFS dependency, right? Okay. In DFS, so first we refactor this into this. So we want these and these. D F D W F. And we give and basically we pass the characters, the digit, word, D1, right? So to find the dependency, right? To find 3, we find it through either T with 8, or finally we have to check for basically the exact letter, right? So in this case, right, if we do T, if any of these branch is found, we good. So T here is 1, but we found them through 8. If we do R, we found them through 4. But if we do E share with a lot of people, which we don't want to do, right? But right, so as long as we can code the D in here, you should be good, right? But for now, let's fix this 3K here. We want to do LFTs and we have 4 more cases, guys. So I'm gonna have to go eat now because I'm hungry. I can't think right.